Alright, so today we're starting with principal inverse values. This is really the beginning of Unit 3. Yesterday we talked a little bit about the range restrictions and how when you reflect sine over the y equals x line, it gives you this shape. And so that shape's not a function, and so we had to restrict the range. And so we chose the restriction. So if I this is a very rough sketch, but I ended up choosing the restriction from here to here. And that restriction is represented right here. So x equals sine inverse of y is from negative 90 to positive 90 degrees. The other restriction, so we also talked about cosine being restricted from 0 to 180. And for those same reasons, we're also going to have these restrictions for the other trig functions. So here's all the restrictions listed out for you. Tan inverse is restricted from negative 90 to 90. Cosecant inverse is going to be restricted from negative 90 to 90. Secant inverse from 0 to 180. And cotangent from 0 to pi. So let's list out all the ones that are from 0 to 180. So all the ones from 0 to 180 is cosine inverse, secant inverse, and, oh, I'm sorry, that pi, we're talking about degrees here. This pi should say 180. I missed one. And cotangent inverse. So we're just going to list all those out. So I said it was cosine inverse, secant inverse, and cotangent inverse. So anytime you see an inverse function of cosine, inverse function of secant, or inverse function of cotangent, you're going to know that the range is going to be restricted from 0 to 180. So if you think back to a quadrant, coordinate plane, 0 to 180 is 0. Then we have 90 here, and then 180 here. So we're only going to be using quadrant 1 and quadrant 2. Alright, for negative 90 to positive 90, if we list out these guys, this is sine inverse, tangent inverse, and cosecant inverse. So sine inverse, cosecant inverse, and tangent inverse. And negative 90 to 90, negative 90, if you remember we start at 0, so if you go negative 90, that's going in the opposite direction. So this is negative 90, and then this is positive 90. So this is the only two quadrants I'm going to use. So what does all of this mean so far that I'm talking about? What this means, if I take a minute, I'm just going to come over to the side. Let's just say we're looking at from 0 to 180. So let's just take one of those. And let's talk about cosine inverse. So if you have cosine inverse, that means that's what is right here would be a ratio. So let's just make up the ratio 1/2. So what this is saying is cosine inverse has a ratio of 1 over 2. Well, cosine ratio 1 over 2, the ratio of cosine is adjacent over hypotenuse. So if I'm telling you that the adjacent is 1 and the hypotenuse is 2, then I can draw that here. If my adjacent is positive 1 and my hypotenuse is 2, then that's going to look like this triangle right here. Well, that's just one possibility. The thing is that I could also draw that same ratio down here in quadrant 4, because that would still have an adjacent movement of 1 and a hypotenuse of 2. This is still, this blue triangle that I've drawn is still cosine inverse of 1/2. And that's precisely why we have to restrict the range, is because when we talk about the principal inverse value, I only want one principal answer. And so I'm going to say, well, only give me the answer that's somewhere between 0 and 180. Don't give me the other answer. Just give me that first answer that you would have, and that would be from 0 to 180. And so that's why we use this one triangle. So what that's going to mean for us is quadrant 1 is always positive, right? And when you talk about positive, I'm saying that your adjacent movement would be positive and your opposite movement would always be positive. And your hypotenuse is always positive. So quadrant 1 is always your positive answer. So let's put a big plus sign here. Now, if we think about what quadrant 2 is, quadrant 2 would have a negative adjacent but a positive opposite. So it's because that adjacent is negative that we say, well, that's why we're going to use quadrant 2 as the negatives. Because for these three guys, cosine deals with the adjacent. It's adjacent over hypotenuse. Secant deals with hypotenuse over adjacent. And cotangent is adjacent over opposite. So these three guys deal primarily with the adjacent. And so now we have quadrant 1 for positive and quadrant 2 for negative. So let's think about that for from negative 90 to 90. We still would have quadrant 1 is always the positive. Quadrant 1 is kind of like the ideal scenario. When you talk about sine and cosecant, these guys are the opposite guys. So if you notice in quadrant 2, your opposite would be negative because you'd be going down. And so that's why we're going to call quadrant 4 the negatives, is because in quadrant 4 that represents going down. All right, so let's go on. Find the exact principal inverse in radians without using a calculator. I'm sorry, let's do degrees today, and tomorrow we'll do radians, but I want to talk about this all in degrees today. So that, just cross that off, that should say degrees. That's why we see theta. Anytime we're talking about theta, we're talking about degrees. All right, so theta equals arc sine root 3 over 2. I don't like arc. Let's rewrite that as sine inverse. It's just my preference on how I see it. Because what I see is that when I have this little -1, this tells me that I'm talking about a ratio right here. So I'm talking about sine's ratio is root 3 over 2. Well, because this ratio is positive, I automatically know I'm going to be in quadrant 1. Any positive ratio is always in quadrant 1. All right, so sine's ratio is opposite over hypotenuse. So if you draw an opposite of root 3 in quadrant 1, so draw an opposite of root 3 and a hypotenuse of 2, if you go ahead and finish off that triangle, this is what that triangle would look like. And I have a triangle that lives in quadrant 1. Well, this is why at the very top, it might have been helpful if we reviewed this. For 30, 60, 90s, 30 had across a 1, 60 with a root 3, and 90 with a 2. While I'm here, I'll just go over the 45, 45, 90. Across 45 is 1, across the other 45 is 1, across the 90 is 2. So the fact that you see a root 3 here and a 2 here, you know that the other side's going to be a 1. This is obviously a 30, 60, 90 triangle we're talking about. Furthermore, if this is a root 3, across the root 3 side is an angle of 60 degrees. So 60 degrees here is the angle in which I created this triangle. And this triangle created the ratio root 3 over 2 for sine. So 60 degrees is the answer. All right, let's do it again. So theta equals secant inverse of -2. So for this problem, secant inverse of -2. Now that you see a negative ratio, you really have to come back up here and say, well, when I have negative ratios, I'm either going to be in quadrant 2 or in quadrant 4. You got to know which one is which. So I actually have a saying for you to remember this, because otherwise you just got to memorize this. And memorizing is just the worst way to go. So my saying is, for cosine and secant and cotangent, how you can remember, it's from 0 to 180. go ahead and write this down because you're going to be saying this. I can guarantee you'll say this in the middle of your test. You'll be saying it in your head. Cosine and brother secant I call them brothers because they're reciprocals of each other. So cosine and brother secant lie on a cot. So what that tells you, when you picture what a cot looks like, a cot is a flat surface, and if you're lying on a cot, you're going to look like this. Let's say you got a big belly. So that's what you look like. So what that's supposed to remind you of, really, is that this is your axis, and you go from the 0 to the 180. So when you say cosine and secant lie on a cot, you're saying, well, this is what a cot looks like, so I'm going from 0 all the way over to 180. Now, there's not a great way to remember this other one, so you just got to remember these first three, and then the other three are the leftover guys. So, once again, if we come back to this problem, theta equals secant inverse of negative root 2. So, how you do this is you say, well, I see a negative ratio. I'm talking about secant. So, go through the saying, cosine and secant lie on a cot. And if you draw that cot picture, this is for positives, this guy's for negatives. So that's why what you see here is quadrant 2. We went ahead and drew the quadrant for you, but we're not going to do that every single time. So that's why you got to start remembering what quadrant it's in. So it is going to be in quadrant 2 because this is a negative secant ratio. So if secant is my ratio, I can put this over 1, and that's hypotenuse over adjacent. So if we have an adjacent of 1 and a hypotenuse of 2, now what you're probably thinking right now is, well, this was actually supposed to be a hypotenuse of negative 2, right? But we never say negative hypotenuses. Negative 2 over 1 is the exact same thing as 2 over negative 1. That negative doesn't have a right or wrong position. They both mean the same thing. So it's actually the adjacent that's negative, the one that's negative. And that makes sense because you went in that left-hand direction. And now we know how to finish off this problem. If we have 1 and 2, that other number must be root 3. And I know across the 1 is 30, so this would be 30 degrees. But more importantly, the reference angle, which is right here, that would have to be 60 degrees. Now, theta ref would be indeed 60 degrees, but that's not the answer. The answer is how do you get to 60 degrees? So this is the final answer that you're looking for. So if this angle right here is 60, then how you get there must be 180 minus 60, which is 120 degrees. All right, let's go ahead and go to the next page, and we'll just do some more examples. All right, so in number 2, cotangent inverse of 0. So you have to go through that process saying, well, is this negative or positive to know what quadrant it goes in? And 0 is a hard number. You can't really say 0 is negative or positive. So cosine secant lie on a cot. This is cot. So we know it's going to be in quadrant 1 or in quadrant 2. Quadrant 1's for the positive guys, quadrant 2's for the negative guys. That already kind of gives you a clue of where it's going to be, because if you can't say it's positive or negative, then it's going to lie exactly in between. That's one clue. The other clue is that cotangent inverse, let's go ahead and put 0 over 1, that's still 0, has the ratio adjacent over opposite. So can you tell me where the adjacent is 0 and then the opposite is 1? First of all, is that even going to be a triangle? If you have a side of a triangle that's 0, is that really a triangle? So you're not really going to be drawing a triangle. That would have a length to it. But you do have an opposite that's 1. So with respect to the origin, your opposite is positive 1. Opposite's like your height right here. So this answer is pi over 2. I'm sorry, we're in degrees. Is 90 degrees. All right, so in number 3, we have theta equals sine inverse negative root 2 over 2. Before I start this, look at this little note right here. This is going to come up kind of often. If you think about what your options are for your special right triangles, your options are 1, root 3, and 2 for the 30, 60, 90s. And then for the 45, 45, 90, we have 1, 1, and root 2. So when you go through these options, you see a square root of 2. So that kind of automatically puts us in this category. We know it's going to be a 45, 45, 90. So if you think about what kind of 45, 45, 90 ratios you could have the ratio, let's say, this guy over this guy. So you could have a ratio 1 over root 2. You could have, well, this would still be 1 over root 2, so I'm not going to write that again. Or you could have root 2 over 1. My point is that if you just really try to put these over a ratio, you're not going to see root 2 over 2. But this is why at the beginning of the year we talked about rationalizing, is because this is actually this guy rationalized. So let's take the first step and say, well, let's rewrite this as theta equals sine inverse of negative 1 over root 2. I guess I really shouldn't cross this off because it's not that this is wrong. It's just that these guys are equivalent to each other. This is just the unrationalized version. This is the rationalized version. It doesn't really help us that much. This helps us a lot more because now I can know, well, across a 1 is a certain angle and across a root 2 is the other angle. All right, so this is a negative ratio of sine. So my saying is cosine and brother secant lie in a cot. Well, this isn't cosine, it's not brother secant, and it's not cot. So it must be this scenario. Because if it's not the other case, it's this case, where this would be positive in quadrant 1 and negative in quadrant 2. So since this is indeed a negative ratio, I must live in quadrant, 4 was this quadrant, not 2. This is quadrant 4. So sine negative ratios live in quadrant 4, and that's why quadrant 4 is drawn for you. Again, don't get used to this quadrant always being drawn for you. It's certainly not going to be. All right, so sine's ratio is opposite over hypotenuse. So if I put my opposite as the 1 and the hypotenuse as the root 2. So let's draw an opposite of 1 and a hypotenuse of root 2. Now it does make sense that this is a negative ratio because when I put a 1 here, since I went down, that must be a negative 1. And if I finish this out, this is a 45, 45, 90, so my other side is also a 1. It is going in the positive direction because it's going in the positive or right direction. And across both 1s is 45, 45. So 45 degrees is your reference angle. Now, if you think about this, how we typically would say, well, from the 0 line, how do you get there? So from the 0 line, how do we get there? Well, the easiest thing to say is I just went backwards. This is going in the backwards direction. I went backwards 45 degrees. So that's negative 45 degrees. And that's the most typical answer that you're going to see. A lot of you may be saying, well, why don't we just go ahead and go in the forward direction and say that that's, what would that be? 360 minus 45, which is 315. That's not necessarily a wrong answer. It's just not the typical way that we do it. The typical way is just to say I went backwards 45 degrees, which is honestly easier. You're just basically going to use that reference angle and put a negative sign in front of it. All right, let's go on. So in example 4, we have arc cosine of negative root 3 over 2. So if we have arc cosine, well, let me rewrite that as cosine inverse, because that's my preference, of negative root 3 over 2. That's so ugly. Negative root 3 over 2. All right. So, as you can see, we stopped drawing the quadrants for you. So, let's go through this saying. I got to know if this is in quadrant 1, 2, or 4. This is a negative ratio, so it's going to be not in 1. So we really got to do this for these quadrants. So if it's cosine and brother secant lie on a cot, this is what a cot looks like. And you would be dealing with quadrant 1 for positives and quadrant 2 for negatives. And since this is cosine and brother secant lie on a cot, this is cosine, then this story fits. I am in this story. I have a negative ratio, so I must be in quadrant 2. So go ahead and draw quadrant 2 nice and big. This is just kind of like my think time to figure out if I'm going to be, which quadrant I'm going to be in. All right, so this is cosine's ratio, which is adjacent, over hypotenuse. So if I try to draw an adjacent of negative root 3, then when I draw a triangle, I want to draw an adjacent of root 3 and a hypotenuse of 2. It does make sense that this was a negative ratio because I would have had to go in the negative adjacent direction. Now, in order to finish this triangle out, you have to know it's either 30, 60, or 90, or 45, 45, 90. 30, 60, 90 is 1, root 3, and 2. 45, 45, 90 is 1, 1, root 2. Root 3 is here, 2 is here, so this is matching the 1, root 3, and 2. The number that's missing is the 1. So this is a 30, 60, 90. Across root 3 is 60, but that's not really that important of an angle. What's really important is the reference angle, which would be across the 1, which is 30. Now the reference angle is good to find, but it is not the final answer. The final answer is from the 0, how do you get here? So if this is 180 and I am 30 degrees less than that, so I will be subtracting. Minus 30 is 150. All right. Theta equals arc cotangent. Man, they keep throwing in arcs. Let's rewrite that as cotangent inverse. Negative root 3. So, let's go through our saying. Cosine, brother secant lie on a cot. This is certainly cot. So, I'm in either quadrant 1 or in quadrant 2. Since this is a negative ratio, quadrant 1 is only for positive guys. So, I must be in quadrant 2 because that's all my negative guys. Now let's see what our ratio is. It looks like our ratio is just negative root 3. But that's not a ratio. A ratio is a number over a number. So let's put that over 1. And cotangent, well, TOA is tangent. That's O over A. So cotangent, if it's TOA, then cotangent must be A and then O. So my adjacent is root 3. Notice I'm not saying it's negative root 3. Let's just figure out where the root 3 belongs, and then the 1 is the opposite, because you never really know if that negative sign is supposed to be on top or bottom. In this case, it is still the top because it's going in the left direction, but it's just as a general practice, safer to not make that assumption. All right, and then this is 150. I'm sorry, the answer is 150. I just totally skipped 2 steps. The reference angle is 30 degrees, so our final answer is 150. I'm sorry, I skipped that, but hopefully you can get there. All right, let's do number 6. Theta equals tan inverse of negative root 3. You can go ahead and think, well, I'm going to have to see a ratio. Let's put that over 1. Let's go through our saying. Cosine and brother secant lie on a cot. This is not cosine. This is not secant. It is not cotangent. So it's the other scenario. It's this scenario. So you're either in quadrant 1, that would be if it was positive, or in quadrant 4, that would be if it's negative. Since this is, in fact, a negative ratio, I must be in quadrant 4. So draw a nice, big, pretty quadrant 4. Drawing these triangles is not an option. I will not take any work without these triangles. All right, this is TOA, O, A. So if your opposite is root 3, that's an ugly line, that's okay, and your adjacent is 1, let's go ahead and figure out which one of these guys would be negative. I know one of them is supposed to be negative, so the opposite, it looks like, would be going down, so it is the opposite that's negative. The adjacent is positive. That's good. They both can't be negative. If they are both negative, it would go back to a positive, right? Finish off the triangle would be a 2. So this is a 30, 60, 90. I know across 1 is 30. This guy would be 30, but we don't care so much about that. Across root 3 is 60. That's the more important one. That's the reference angle. The answer, though, is 0, go backwards 60, and when you go backwards, that's negative. All right, and sine inverse of 0. So if we're doing theta equals sine inverse of 0, so sine inverse, cosine, secant, y on a cot, that is not any of those things. So I must be in quadrant 1 or 4. This is kind of one of those, again, you can't really say if 0 is positive or negative. That's already kind of a clue of where you're going to land. But if you just want to confirm it, so if you can't say if it's positive or negative, it's going to be right in between. But if you want to confirm it, then 0, let's put that over 1, opposite over hypotenuse. So is the opposite 0? So your opposite is your up to downness. Your up to downness only happens 0 right here. So this is correct. And so this is 0 degrees. Okay? So in general, how we answer these. You know what, let's just ignore that. Just draw the triangle. I mean, if you just draw the triangle, this is just a rule. I hate rules. Just draw the triangle, figure out where the reference angle is, and then how you get from the 0 to the reference angle is the best way to do this. Okay? And that's all.